So we're going to calculate the molar solubility of silver sulfate in the presence of 0.01 molar sodium thiosulfate. Okay, so silver sulfate, I went and looked up the KSP and the KF values. Now what I'm going to do is write my solubility product equation. So I get 2 silver ions, and then I get sulfate. And ions are all soluble, and if I don't write it as ion, it's insoluble. Okay, so that way you don't have to write all the states. And this is going to be 1.2 times 10 to the minus fifth. That's the KSP. And then I have to combine it with the KF for silver thiosulfate. So I get Ag plus 2 S2O3, 2 minuses, and that gives me the complex ion. And that has normally a KF of 2.8 times 10 to the 13th. Catch in this problem is, though, in order to get these to combine properly, you need the silvers to cancel out. So you need to double this. Which means you need to square that. So then I can write a new reaction from this, making sure to cancel the silver ions. And then I get silver sulfate, again that's the solid, plus 4 thiosulfates. It'd be in equilibrium with sulfate. Actually, let me put the metal first, although it doesn't really matter. But 2 Ag, and then S2O3, 2, and a minus 3 charge, plus sulfate. And then I need to calculate this new equilibrium constant. But if this was, we're doing molar solubility, we have a fixed concentration of thiosulfate. So, because that's what it means by in the presence of. So I'm not going to think about this until the equilibrium line, but normally when you do solubility products, this would be 2S, and this would be S, K, and this is going to be K net, is going to be 2S squared times S divided by the concentration of thiosulfate. I don't know why I did it that way, but I did. To the 4th power. I should have written these symbols over here, but I don't know why I didn't. Tired. So this is going to be 4s cubed on the top. And then the bottom is going to be 0.01 to the 4th power. So K net, I need to multiply these two together, so I'll go ahead and I'll pull up a calculator. And we're going to just very quickly 1.2 times 10, the negative fifth, times then 2.8 times 10 to the 13th squared. So 2.8 E13, and I'll square that, and that equals, and I'll put it in scientific notation. That becomes 9.4 times 10 to the 21st. So got a little distracted, but anyways, back on task here. I need to solve this part of the equation over here. So I'll go ahead and calculate this. S cubed will be equal to 9.4 times 10 to the 21st times 0.01 to the 4th divided by 4. So let's go ahead and do that. So times 0.01 to the 4th power divided by 4. So that becomes 2.35 times 10 to the 14th is I think what it said. 13th, sorry, 13th. Yep. And then I need to get the cube root, so that's the 1/3 power. So that's what I'll do. I'll raise this to the, you could type in 1 divided by 3 in parentheses, or let's add that. And then you get 2.86 times 10 to the 4th. Something like that. 2.86, well, it would be 2.87, I guess, if you rounded it. So that's kind of one of those, well, that's ridiculously high numbers, which means if you could buffer the thiosulfate concentration to this value, 0.01 molar, you can basically dissolve as much silver sulfate as you want into the solution. Because in essence, it'll completely take the form of the complex ion.